So, thank you for the opportunity. Looks like maybe we could say that the name of the event could be Selenium Conference, Apple Conference, and this WebDriver BiDi Conference, for the way that we been. Every talk is talking about BiDi. So, oops. I'm working at Galia since 2020. Previously, I worked on actually, I started my career in the Maemo days from the Nokia times. Who remembers the Maemo from Nokia? Jesus, I'm old. But I also worked on JS and C# bindings for EFL. And at Galia, at the WebKit, I work at the WebKit team. I started doing QA work, so this area of testing and validation is something that I kind of always worked with. And lately, I've been working on improving the WebDriver support in WebKit. We are a software cooperative, a consultancy, flat structure. We are among the top contributors to all of the major web engines. The compilers are JavaScript and rendering spec. We do a lot of work in the WTC, and also we work on other areas like graphics and so on. So, first we are going to see what is WebKit actually. How do we support WebDriver Classic in WebKit today? The work that we have been doing to add the BiDi support, the challenges that we are facing, what are the next steps, and how we can work together. So, WebKit. First of all, WebKit is not Safari. And just like 2 years ago, David gave a nice presentation about some misconceptions that we have about sometimes thinking, okay, it's just WebKit, so if I run this against WebKit, it will run against Safari. No, WebKit is much more than that. And WebKit is a web rendering engine. It's open source. Actually, it's originally was the KGML and KJS from KDE in the early 2000s. There was some point in the past that Chrome used WebKit before forking to Blink. And one of the main characteristics of WebKit is that it supports many different platforms. We use WebKit on desktop, we use WebKit on mobile, and also on embedded devices. Not embedded like cell phones, but truly embedded device. But who uses WebKit? Safari, obviously, is the main use case. The mail application, the GNOME web on Linux, the browser, Evolution to read emails. PlayStation uses WebKit. Your set-top box, especially I think in the US, might be using WebKit, believe it or not. And even kitchen mixers are using WebKit. Really? Yes, that's a browser running WebKit over there. So how what's the architecture of WebKit? First of all, we have the application that what the browser developer ends up writing, the developers of Safari or of GNOME Web, etc. Then we have the library, which called WebKit, which exposes it's a visible API to the developer and implements the multiple process of WebKit. We have a piece called WebCore. That's most of the let's say low-level code and code shared between the different WebKit versions for implementing let's say the spec says that CSS must be rendered that way and so on. That goes usually in WebCore. The JavaScript core engine for JavaScript, which in the case of Blink is V8. And we have, given that we are multi-platform, we also have some platform-specific hooks that we'll be talking about it later. So WebKit's, well, the main characteristic is that it's cross-platform, but we need to interact with the system. For example, networking, I'm not going to use the same network library on Linux and on macOS. And the same for graphics, for multimedia, and user input. All those things are system-specific. And if I'm using WebKit on my system, I may want to wrap WebKit in an API that's closer to the way that the developer will be using, like different UI toolkits. So, just like I said, for implementation of low-level operations, we could use core APIs on Mac, glib and GStreamer on Linux. Or in the case of Mac, the WebKit is exposed like what they call the framework, while in Linux it's a G-object-based API. So we have this concept of ports that we use in WebKit lingo that is, how can I say, maybe like a flavor of WebKit adapted for a specific platform or API. There are many upstream WebKit ports. So we have Mac, the Mac port, its broader port, the iOS, the WinCairo, which is used by Playwright and the PlayStation SDK, the PlayStation ports that actually runs on PlayStation. Also, we have the WebKit GTK and the WPE WebKits, which are the two ports that we work mainly. I work on the day-to-day. The WebKit GTK for desktop Linux and WPE WebKit to run on embedded devices like the mixer and the set-top boxes. It's a stripped-down version of WebKit. And in the WebKit website, there's some documentation about the ports. And just to give another example, in the case of WebKit GTK, we have libsoup for the networking. We use GTK for widgets and Skia for low level. Previously, we used Cairo, GStreamer for multimedia, and wrap all that in a JObject API. Just like in any major browser nowadays, WebKit is multi-processes. So the concept of the relationship between the processor is important to understand the WebDriver implementation later. We have the UI process, which is the browser executable, be it Safari, GNOME Web, etc., mini browser, etc. It's in charge of interactive handling user input, display, talking to the system compositor to show the handled pages and the Chrome of the borders of the browser, and to manage all those processes that will be running. We have the UI process, which acts like a sandbox to isolate JavaScript, because the last thing that you want is some JavaScript that you got somewhere from the deep net with access to your system. So this is tightly sandboxed, and also the web process is in charge of painting the page, so rendering the page from the DOM trees that it also handles. It creates a visual set of tiles representing the page and pass to the UI process. And then we have the network process, which takes care of talking to the outside world, be it on the internet, doing requests and so on, or working with local caches and local storage and these kind of things. And the communication is through some platform-specific IPC. We are working to harden this communication to avoid security issues. And it's platform-specific because on Linux you are going to use one kind of IPC, and on Mac or other platforms you are going to use others. So just a picture, so the relationship between the process, where the UI process can command a number of web processes which are related tabs, related views, etc., and then the network process. So now, back to the automation, WebDriver Classic in WebKit. The first reference that I could find in the WebKit blog was from 2016 about adding support to the WebDriver in Safari 10. At the time, the WebDriver spec was under heavy development. So the implementation of WebDriver in WebKit, currently it's kind of split between some code inside WebKit itself and some inside the drivers. And the support of some commands, etc., can differ between the ports. And some features may even ask the browser to do the work. For example, when you want to create a new window, etc., WebKit, instead of creating the window out of nowhere, uses the port API to say to the browser, please open a new window for me. And then the browser do the work. We have two drivers, mainly. The first one is the WebKit WebDriver, which is the open source one that lives in the WebKit repo, which is the one that we are going to be talking about it today, mainly. It's used nowadays by WebKit GTK, WP, WebKit, WinCairo ports. We also have the Safari driver, which is closed source, and it's tied to the, its focus is on automating Safari, so it's closely tied to it. But both drivers use the same protocol to talk between the driver and the browser. So it helps sharing some code. And as mentioned, we are going to focus on the open source part of the open source driver, which is the WebKit WebDriver. There we run the WebDriver Classic HTTP server, like the spec says to run. The driver manages the spawning and the lifetime of the browsers, but it also allows you to, I already have a running WebKit driver, a WebKit browser, so the driver can start and connect to that run browser, which is useful, for example, if you are automating on an embedded board where you can't just go starting the browser all the time. It takes some seconds to spawn. Nowadays, the driver also does some initial heavy lifting for the commands, like the initial capability negotiation, where I think not so sure if all, but most commands on the spec, especially commands that have side effect. They say that first you need to handle the open, if there's any open dialog. And then you have to wait for the navigation to complete, etc. Nowadays, this is done on the driver side, so we have to wait there. And as I mentioned, the WebKit WebDriver uses the Web Spectrum protocol to talk to the browser. Just like CDP kind of uses the CDP-based tools built on top of the CDP protocol, we use the inspector, which is already async, so it's a good thing that it's already supported. But currently, the WebKit WebDriver is limited to at most one browser running, one active session, one browser running per driver instance. On the browser side, we have an entry point on the UI process to do the stuff that needs to be done on the UI process, and do the command dispatches. For example, on the UI process, when you want to perform an action through WebDriver, you need to what WebKit does is to create a set of synthetic events, input events, using the port API, and then submit to the browser to simulate like if you were actually using let's say you are using the WebKit GTK. So the driver on the WebKit on the browser side will create GTK events to send to to the browser to be processed. This is to avoid it creating the events deep inside WebKit, and we would be losing some bug that appears on the front while translating back to the shared code in WebKit. But some codes need to touch the web content, like I think one of the most common commands is executing some custom JS or get information about the elements, so that we have a class also on the web process that talks to the web automation to handle this on that side. How do we test these implementations of WebDriver in WebKit? So we have a set of imported test suites into the WebKit repository. So we have we use the Selenium Python, because WebKit tooling is mostly Python. And also we have the web platform tests to validate it against the spec. Unfortunately, there are some long intervals between updating the test suite in the past. Sometimes over a year it's spent between updates. And this led to, at some point, the WebKit GTK WP code in Selenium to be outdated. There are some issues. We are trying to be more active, to follow the Selenium development and to keep the code updated, contributing there. And let's say, for example, checking the support every quarter or closer to the Selenium releases. We use a minimal browser that called mini browser for testing, so that we can validate without having a larger browser. We run on post-commit CI in WebKit. So when you submit a PR to WebKit, we don't test automatically WebDriver before committing. So we are somehow still in a reactive state related to WebDriver. And they are only run against WebKit GTK and WPE WebKit, that Igalia maintains the bots for this. And keeping the test suite green is kind of challenging, mainly due to the lack of pre-commit hooks, and also due to the lack of manpower to be working on juggling all those tests, because testing browsers, test web applications is hard. And testing browsers is also very hard to keep it working. We also use the wpt.fyi, which runs the tests from the spec. So this is from a couple of days ago. We see that WebKit for WebDriver is a bit red, let's say. But the good thing is that BiDi is already starting to get some movement here. More on that later. So some limitations on the support for Classic in WebKit. There are some code in the browser that's stateful. It's related to that concept of having a current browsing state that the command will be running against. One session per driver, which makes things harder to scale up testing. Some smaller bugs, like tracking the non-elements references, that makes an error return a different kind of error. This is the kind of thing that makes some of that redness. And also, we have some shortcomings from the WebDriver Classic itself, from the protocol itself, which is the browser, following the protocol, the browser can tell the driver and the client that something has happened. So we have to rely on polling, but polling, who here had problems with polling in the past, in the tests? Okay. So there, especially if you need to react as fast as possible when something happens, it's something that's not feasible. It can be expensive to be asking the browser all the time if something is happening. So we need some kind of bi-directional solution for that. And the industry over the years came up with different solutions, like the ones built on top of CDP, and we took advantage of that as a community to develop the BiDi spec. So a quick overview of the BiDi. It's a WC standard being under development. It's advancing to the working draft status. Already has good support for Chrome and Firefox, like we saw in the dashboard a few slides before. The BiDi, the name, stands for bidirectional. And like I think it was Pooja that mentioned, it builds on top of WebDriver Classic. So that we can start adopting BiDi in an incremental way. We don't have to wait for it to be completed, then jump, which is exactly the case of working with BiDi in WebKit. It's synchronous by design, and now the browser can push events to the driver. So what about the support of BiDi in WebKit? The first step, originally I was working on a separate branch based on older version, but now all the code related to BiDi, we are working directly on WebKit upstream. The initial work and the focus of my day-to-day is on the WebKit GTK and WPE WebKit port, but basically all the code is shared with other ports. Basically, what's related to this is setting up a WebSocket server using libsoup. The actual, let's say, the most part of the BiDi spec work is shared or is ready to be used by other ports. So we already support setting up the server, server creation. We support basic log message events. That was something that I keep in mind that if we are going to start supporting BiDi, let's start supporting aiming to support the things that are new in BiDi that will bring more value. And if I were just adding comments to perform actions, to navigate, etc., this is already covered by the Classic API. So it can be wait, and then I focused on adding support for events. And to validate, I'm using mainly, like I mentioned, Selenium Python and the WPT WebDriver libraries, because it's already covered in the CI, and we are using it. So after those first steps, we are now in a phase, let's try to scale up the support for BiDi. The first prototype, it had some handwritten processing of the JSON messages. So it came a command, I was going to manually in CPP code asking, is this field present, is not present, etc. And it worked well for this simple scenario, but BiDi is very big, so it has recursive data structures, these kind of things. So we need to be better. So Blaze from Apple added support recently to define in a declarative way. So it will be much faster to add support for new BiDi commands, because the parsing will be automatic now. And it's also one focus that we are having with BiDi now is to focus on sharing on as much code as possible between the ports, to avoid that problem of having different browsers and people complain about Safari driver, about WebKit WebDriver, and to take advantage of the community efforts. So we are now polishing this scheme to follow the implementation of the new BiDi commands and the event system. Right now, we support session creation, still limited to one session because we are creating mixed classic BiDi sessions. Log events, which the text payload, so we don't have extra console parameters and information like stack trace. This will be added. And I'm going to do a quick demo for it. For example, here we have, it's just from the MDN, the bouncing ball demo. where we want to be notified when the ball hits the board and changes the direction. It will be running every 60 milliseconds. And with BiDi Classic, the usual way is to set up some interval. The first thing, in this case, we also need to have some support code that we inject into the page to store the events. And then we set some interval and try to get this. In real life, this would be wrapped into some wait condition, this kind of thing. But this is kind of to see what's under the hood, let's say. So on this, if we are going to run the bouncy ball, this is just to get the output. I'm going to count how many times the driver is going to ping the client is going to ping the driver to ask about information. So the ball is bouncing. We are getting some events. Oops. We are getting sometimes we get more than one event between polls. That's why we have to store the events that happen. And in those 10 seconds, we had 14 queries between the client, the Selenium client, and the driver. Now, if we want to really get, let's say, I want to react as fast as possible. Let's reduce the interval of the polling. Okay, okay. Oops, it's not enough. I would still need to go faster polling. But we already grew to 54 queries between the client and the browser and the driver. And remember that this query is executing a JavaScript command that goes to the browser, goes from the client, driver, UI process, web process, and then goes back. So it's wasting some resources. Now, what about with BiDi? In BiDi, we would get, this is already Selenium Python code, which added support some time ago to log events. So we add these process events, and then we are going basically the same code, running I'm not changing the HTML, which it only has those, console logs, which I'm using as a way to push the message to the browser. Now with BiDi, BiDi it's running, okay. So we get one event. As soon as the ball hits, the event gets, and then we get timestamps and all the niceties from events and so on. In the BiDi spec, there's another way to do this, which is using adding some preload scripts and exposing what they call a channel that you can use to push message to the browser. But it shows that I forgot, I did not show. But we had only 3 round trips between the driver and the client. So it's like if you create some wait condition, but instead of this wait condition living on the browser, it lives inside living on the driver. The condition will live inside the browser, and then you can do things much more efficiently there. So some challenges that we are facing. First of all, it's the multiple active browsing contexts. In BiDi, you can send commands to different browsing contexts repeatedly. And it's different from the stateful approach of Classic. So it's something that we need to keep in mind, because there are some code mailing on the driver side that still has those assumptions when they were written. And also multiple user contexts, like there was the talk earlier today about it, where we can have the same browser instance, but with different separate sessions running. So the implementation of BiDi in WebKit must be able to create those different user contexts, subscribe to events on those different user contexts, and keep working normally. Currently, mini browser lacks support for this, and we also probably need to add some API to the developer facing, because I'm writing, let's say I'm creating a custom WebKit browser. I want to be notified if the user wants, if the browser wants to create a new user context, because I might need to set up the data partition in a different way, this kind of stuff, some customization. Also, the BiDi event systems, because they are very powerful, you can subscribe to events on different browsing contexts, different user contexts. We can have different priorities for events. Let's say that you are going to, you ask to subscribe to 2 different events on a given browsing context. Then those events have some steps of subscription that must be taken when subscribing and must follow some kind of priority. And the current inspector protocol between the driver and the browser might not be enough for this, so we are planning to move the event implementation inside the browser itself, also to avoid doing all those round-trip calls between, and also to share as much code as possible between the ports. So the next steps for BiDi itself, we need to implement some basic BiDi commands that the WPT test uses, which are to get a tree of browsing contexts, and to navigate to specific pages, to evaluate JavaScript functions. Those are, let's say, the 3 cornerstone commands for WPT. Finish supporting the Selenium Python BiDi features, because we are using Selenium BiDi in CI, so Selenium Python in CI, so that's natural that we are focusing on it. And keep track of the developments there. And other sources that we are kind of following to help prioritize the work is the BiDi features in other Selenium languages. They are more in a more advanced state than the Python one. The Puppeteer BiDi support that was added recently, and other low-hanging fruits that might appear in the spec and the roadmap. On the QA side, we need to guard the current failures, to keep track of them, and to help adding pre-commit WebDriver tests to avoid things breaking and we having to chase them. Also, something while working on the browser area, it's usually most of the focus is on the speed of the browser, on the memory consumption of the browser, and on shiny new CSS, HTML features, etc. But we are trying to get closer to the testing community to ensure that WebKit works nice. It's a good experience. It's not something that brings some headaches. And for that, we are going to update the test suite more frequently, test the new versions of Selenium, of other tools, to make sure that they keep working with newer WebKit. And do not forget about WebDriver Classic, because it's still around. It is still going to be around for a while. So it's something that we want to keep working. About contributing to WebKit, we have this page on the WebKit site. But the main thing that I think that would be most helpful right now would be tracing and gardening, helping to keep track of the failures. Right now, we have about 190 open bugs on the WebDriver component. I think that maybe 1/3 of this is related to the BiDi implementation, so it's not as bad as it seems. But one of the issues is sometimes we miss information about the failures. Sometimes it's we don't get it. Sometimes people say, this is not working. There's no examples, no hint of why it might not be working or some kind of tests. So validate if the bug is still present, because some of those is very old. Also, we have to keep track the BiDi work. And this will help making the WebDriver CI to go green and hopefully move it to the pre-commit hooks in GitHub. So, recap. WebKit is not Safari. It's a browser engine used by many use cases, and this brings it's all different kind of people to be cooperating, but at the same time brings some challenges, support on this that we need to work. Currently, we have support for simple BiDi log events, and we want to work closer with the testing community and the WebKit community in general to help prioritize the BiDi work and ensure that the implementation that WebKit has been doing is sound. So in general, BiDi work in WebKit is spinning up, so stay tuned. Probably we are going to send new updates in the Web Engines Hackfest that will happen not so nearby in Coruña, but in Spain. In June, we are organized it. And the WebKit Contributors Meeting, which should be in the Bay Area in the second half of the year. So that's it. Questions? Thank you.
Any questions? I wonder where does he get all the strength to work on this stuff? Probably from the cute little post-it from here. Probably has a story behind it.
The post-it? Yeah. No, it's just a kids.
Right, okay.
Kids thing.
All right, folks, any questions? Yes.
Yeah, thanks for this interesting information. I wanted to ask you about using the WebKit driver with the Safari and controlling the Safari. Is this possible, or should we use the Safari driver for that?
About Safari, I can't say much because basically it's closed source. So I never used Safari.
Okay.
But we are talking to other developers, and the ideal goal is that yes, maybe you could, from the point of view of the WebKit project, that you could use an open source driver to control it. Let's say that will be the most benefit. But I can't say that what are the plans, etc. Because I can talk just about the open source WebKit part of the project.
Okay, so you just, or we can just take the version which they use for developing the Safari, the WebKit version, and then this should work, but you don't know when this is used. And when they switch the next version to WebKit for the using this inside Safari, you don't know.
No, I can't say that.
Okay, great. Thanks.
Thank you. There you go. Christian. Probably find a seat in the front, Christian.
I think you mentioned it already, but could you speak towards WebKit not being Safari and this implication, what that means for testing applications?
Okay, WebKit's not Safari, and I think the main implication is that to be aware that if you are testing our web application against WebKit, there could be some issues that might not you might not be testing that related to Safari, and that could be issues that are related to that WebKit browser that you are using. So sometimes there, I think not most of the time, but there's issues that are typically from the engine that will appear anywhere. So that those are the easy ones sometimes that you can get a developer to reproduce on Linux, on Mac, on whatever, and work, and all the community will benefit. But I think one of the examples that was from David's talk, it was from an issue that appeared only on Safari on desktop. So that's, let's say that you are using Playwright to test that doesn't use the Safari version, that would go under the radar, so you might not, you'd be, let's say, you'd be tied to the peculiarities of that specific WebKit browser that you are using. The idea is to, in WebKit, is to reduce that as much as possible. But for example, if you have bugs related to media playing, that's tightly related to the multimedia library that you are using, you need to ensure that you are using the closest version to production as possible.
Any more questions? All right, seems like a wrap. Thank you everyone for joining. Thanks, Lauro.
Thank you.